Albert Einstein, an icon of science, a man we all know for his brilliant mind. But did you know he was once seen as a lazy student who never bothered with mathematics? Yes. His professor at the Swiss University, ETH Zurich, a mathematician named Hermann Minkowski, even went so far as to believe that Einstein would never be capable of revolutionizing our understanding of the universe. Imagine that. And though Einstein was indeed a low performer in Minkowski's class, often skipping class and showing little potential, he still went on to develop his special theory of relativity that turned the world of physics upside down. But that's not the most astonishing part. The most fascinating twist in this tale lies in the contribution of Minkowski himself, the very professor who once dismissed Einstein. Well, you're going to find out soon enough. What's up, my amazing and curious folks? Ready to unravel mysteries together? I am your host, Cesar, and with me today is Sonia, our brilliant commentator.
Hi, everyone. Can't wait to dive into today's topic.
And remember, if you're as fascinated with curiosities and records as we are, make sure to subscribe to our channel and hit that bell icon so you won't miss a beat. Now, let's get our minds blown, shall we? Just like many of us, Albert Einstein's early life was a mix of people who believed in him, but also those who doubted his abilities. One of these people was his professor, mathematician Hermann Minkowski. Minkowski, a child prodigy himself, who won the French Academy of Sciences Mathematics Prize at only 18 and earned his doctorate at just 20, was regarded as a daring mathematical genius. He was best friends with David Hilbert, one of the greatest mathematicians of the 19th and 20th centuries. Minkowski had Einstein as a student at the Swiss Public Research University, ETH Zurich, and he remembered Einstein as a student who was always skipping lectures. Minkowski referred to Einstein as a lazybones who never bothered about mathematics at all, and remarked that Einstein's mathematical education was not very solid.
Really? Well, that's surprising. But how did Minkowski evaluate Einstein's performance?
Minkowski judged Einstein based on the quality of his work on the problems assigned to him. He looked at whether Einstein could understand the problems and use his foundational knowledge to solve them. Performance in a field like mathematics usually involves assessing the student's comprehension of assigned problems, their ability to set up the mathematics correctly, and their ability to carry out the necessary steps to reach a solution.
Could you provide an example to clarify this?
Surely. Let's say the problem is about calculating the area of a complex geometric shape. The first step would be to understand what is being asked, which in this case is the area of the shape. Next, the student needs to properly set up the problem, which could involve breaking down the complex shape into simpler ones. Finally, the student needs to carry out the calculations to find the areas of these simpler shapes and add them up to get the total area of the complex shape. If the student fails in any of these steps, their performance would be considered subpar.
Ah, I see. So in Einstein's case, he wasn't performing well in these areas?
According to Minkowski, yes. But as we know, performance and potential are two different things. Einstein is the perfect example of that. In addition to the quality of a student's work, professors also look at their participation in class, the depth of their questions, and their curiosity. These are also factors that can give us an insight into a student's potential. However, despite these assessments, Minkowski viewed Einstein as a low performer. He noted that Einstein often skipped class, which, as we know, is not the best strategy for someone aiming to revolutionize our understanding of the universe.
Did Einstein's actions and performance in class affect Minkowski's perception of him?
Absolutely it did. In Minkowski's own words, he said, "Oh, that Einstein always cutting lectures, I really would not believe him capable of it." He was surprised and in disbelief that his former student, who he remembered as lazy and uninterested in mathematics, could conceive the idea that led to the development of the special theory of relativity.
So Minkowski didn't see any potential in Einstein at all?
It seems so. In fact, Minkowski had a critical assessment of Einstein. He said, "The mathematical education of the young physicist Albert Einstein was not very solid, which I am in a good position to evaluate since he obtained it from me in Zurich some time ago. But as we know, Einstein went on to prove all of Minkowski's critical assessments wrong.
Can you give us an example where a student's potential was underestimated, but they went on to achieve great things?
Sure. One example that comes to mind is Thomas Edison. As a child, Edison's teachers thought he was too slow to learn and told his mother he was addled. But Edison's mother didn't believe this and took him out of school. She homeschooled him and helped him realize his potential. As we know, Edison grew up to be an inventor of great renown, giving us inventions like the phonograph, the motion picture camera, and the practical electric light bulb.
So it just goes to show that assessments and potential are not always aligned.
Exactly. Performance in school is not always a predictor of one's potential or future success. It's very important to remember that performance and potential are not the same thing. It's easy to judge a person's potential based on their current performance, especially if they are young, inexperienced, or poorly prepared for the challenges they're presently facing. But that is a mistake. There are students who have the capacity to perform at a high level, but have not yet developed the right study habits. Or students who have deep insights and can ask profound questions, but whose problem-solving skills need work. There are also students who have the potential to be very successful in a field, but haven't yet figured out how to properly apply themselves.
So just because a student isn't performing well, it doesn't mean they don't have potential.
Exactly, Sonia. It's easy to look at a student's subpar performance and conclude that this student doesn't have the potential to succeed, but that masks the truth. Performance and potential are not the same things.
Can you give us an example to illustrate this?
Sure. Let's think of a young athlete. They might not be the fastest runner at their first few track meets, but if they have the commitment, the willingness to train, and the determination, they have the potential to become a top athlete. Their current performance doesn't reflect their future potential. It's a similar situation with students in a classroom environment.
That's enlightening. So it's crucial to give every student a fair chance, right?
Absolutely, Sonia. A student you dismiss today may turn out to be a tremendous success tomorrow. It's important to remember that many students want to pursue advanced studies in fields where they've demonstrated less than exceptional performance up to now, and many of them will indeed go on to achieve successful careers in those fields. It's interesting to note that there are students who are yet to realize their full potential. They might not have been pushed to exert a sustained effort, or they might see their current limitations as barriers. Some students only need a problem that truly interests them to motivate them to work up to their potential. On a similar note, I recently read about a student who was struggling in her math classes, but when she took an art class and found a way to incorporate mathematics into her artwork, her performance in both subjects improved significantly.
That's quite insightful. It's funny you mention this because I noticed something similar in my cousin. He was struggling in school until he discovered his passion for music. When he started to understand how mathematical patterns exist in the structure of music, he began to improve in math too. His enthusiasm for music triggered his interest in a subject he was struggling with. It's amazing how extracurricular interests can sometimes illuminate academic potential.
Yes, indeed. It's a perfect example of how some students may need a unique approach or a different perspective to truly unlock their potential. Just like Einstein, who perceived the world differently and revolutionized our understanding of physics and the universe. He continued to pursue his interest in physics and mathematics, even when he was working at the Swiss Patent Office.
It just goes to show that a person's path may not always be straightforward, but that doesn't mean they can't reach their destination. It also emphasizes how important it is for educators to recognize and nurture the potential in each student, even when their performance might not initially meet expectations.
It's important to note that, contrary to popular belief, Einstein was far from being a lone genius. His success was greatly influenced by the community of physicists, astronomers, and mathematicians that he was a part of. His friends, colleagues, and professors all played a key role. Among them were his friends Conrad Habit and Maurice Solovine. who accompanied him on his journey of independent study.
So, collaboration and interdependence are crucial in the path to success?
Yes, it's often the case. Individual brilliance is important, but without the support and collaboration of others, even the most brilliant ideas can fail to bear fruit. Einstein's extracurricular studies were predominant in developing the necessary skills to turn his ideas into solid physical and mathematical theories.
I see. Einstein's persistence and continued learning even outside the formal educational setup really paid off, didn't it?
It certainly did. His independent studies and collaborations led him to rethink the properties of objects moving at speeds close to the speed of light. This line of thought eventually culminated in his special theory of relativity, which he published in 1905. Imagine this, the very same year he published not one, not two, but 5 remarkable papers.
That's quite an accomplishment. It shows how consistent effort, continued learning, and collaboration can pave the way for monumental breakthroughs. This definitely adds a new dimension to our understanding of Einstein's journey.
Now, let's dive even deeper into the remarkable year of 1905 for Einstein. His first published paper that year was on the photoelectric effect, a work that would form part of the foundation for quantum mechanics and for which he was awarded the Nobel Prize in Physics in 1921.
So, even though Einstein is so closely associated with the theory of relativity, his Nobel recognition was for his contribution to quantum mechanics?
That's correct. His second publication in 1905 was not a paper, but his doctoral dissertation, which he completed with Alfred Kleiner at the University of Zurich. He was investigating the dimensions of molecules, and particularly leveraging a new method for calculating Avogadro's number, the number of atoms in a mole. His initial estimation was off by a factor of 3, but subsequent refinements led to a value that was only off by 9%.
Amazing, considering he was working on this outside of a traditional academic environment.
Yes, and his third publication that year was on the topic of Brownian motion, the seemingly random motion of small particles suspended in a stationary liquid. This work supported the kinetic theory of gases and affirmed the physical reality of atoms.
And then came the special theory of relativity.
Yes, exactly. The fourth publication of 1905 was the special theory of relativity, and his fifth and final paper of that year, it gave rise to his most famous equation, E equals mc squared. This equation would later play a crucial role in the development of nuclear-powered rocket engines.
It's truly astounding how much Einstein contributed in just 1 year.
Indeed. And it's a reminder that it's not always about how much time you spend in a classroom, but rather how you apply your mind and think creatively that can lead to breakthroughs. Minkowski, Einstein's teacher, perhaps missed this, as he seemed to have been more focused on mathematical rigor and a narrow set of details rather than fostering Einstein's strong physical intuition and creative problem-solving abilities. Einstein's groundbreaking work played a key role in shaping the direction of scientific thought. Minkowski, despite his earlier assessment of Einstein, was quick to work on the very problems that Einstein had brought to the forefront. He published a paper elaborating on special relativity in 1907 and 1908, where he reframed Maxwell's electromagnetic equations in a 4-dimensional, relativistically invariant formulation.
And that's what led to the notion of space-time, right?
Yes, exactly. Minkowski was the first to develop the notion of what's truly invariant in relativity. Not space, not time, but rather the difference between the square of them, known as the Einstein or space-time interval. He developed a new tool for representing space, time, and the motion of an object through it, the Minkowski diagram. This tool allowed for the generalization of Newton's laws of motion to relativistic regimes.
That's a significant leap in our understanding of the universe.
It indeed is. Minkowski's work paved the way for Einstein to develop general relativity, which is our current best theory of gravitation. Minkowski gave a famous lecture in 1908 where he stated that space and time could not sensibly exist on their own any longer. They were destined to fade away into mere shadows, leaving behind only their union as an independent reality.
So, Minkowski's story serves as a reminder to cultivate potential and encourage creativity, rather than solely focusing on performance.
Yes, his legacy emphasizes the importance of not dismissing the potential of students based on their performance alone. With the right kind of nurturing and hard work, they may surpass anything you can imagine for them. Einstein's story and Minkowski's response to it indeed serve as a testament to this. So to wrap it all up, Einstein's early life was marked by naysayers, notably his professor Hermann Minkowski, who saw him as a lazy student. But Einstein would prove him wrong by revolutionizing our understanding of the universe with his relativity theory.
Not only did Einstein prove his doubters wrong, but his work even inspired Minkowski to develop the concept of space-time, furthering our understanding of physics.
Exactly. It goes to show us that potential isn't always revealed in performance. It reminds us not to judge someone's abilities based on what you see at first glance. A lazy student can turn out to be a revolutionary physicist.
Absolutely. We hope this episode has been as enlightening for you as it has been for us. If you enjoyed listening to our deep dive into the life of Einstein, make sure to blast that like button.
And don't forget to share this episode with your friends. Who knows, you might inspire the next Einstein.
And as usual, we'd love to hear your thoughts, so leave us a comment. Until next time, thank you for joining us on this journey of discovery.
Goodbye, everyone, and keep questioning the world around you. This insightful information came from an article titled, "Einstein's Top Professor Didn't Believe in His Abilities," written by Ethan Siegel and published on the BigThink.com site on October 17, 2023. You can find the full URL in the video description if you want to delve deeper into the subject. Now, I'm off.